Good day, students! By the way, I am teacher Ninya, and for today's discussion, we're going to tackle about calculus. So, when you hear the word change, what comes into your mind? Alright, the only thing that is constant in this universe is change. So everything around us is always changing. We see things moving. The weather keeps changing. The price of things are always changing. And also the temperature of the earth keeps rising. And in addition, our population keeps increasing and many more rising. So, wouldn't it be amazing if we can predict how things are going to change? Well, in many cases, calculus is the only branch of mathematics can do this. Okay, so for example, calculus is used for analyzing the motion of object and then to build the models to predict the trajectory of things like rockets. It can be used to analyze the money coming in out to the business and then to build models to maximize its profit. So calculus can be referred to as the mathematics of change. Alright, so calculus is the mathematics of change. So, these things that is written in the screen, the limits, differentiation, and integration are the important ideas around which calculus is built. So first, we understand these ideas in calculus if we mostly study things which change according to a pattern. Okay, so these patterns change are mathematically represented by the concept of functions. Alright. So the concept of functions is the main object of the study in calculus, and therefore we will understand it well. So finally, we will see how to use the ideas of limits, differentiation, and integration to analyze the functions. So stay tuned. So earlier, that was just a refreshment discussion for you to know the basic terms or the basic history of the calculus. So, to go deeper, let me give you a situational explanation so that you can go beyond or you can get to know more about the topic. So, what will be the amount of water accumulated in an hour? One hard way would be to count the number of drops and calculate. Is there a better way? Let's say we analyze the situation and get the rate of drops falling per minute. It is the constant. It is 100 drops per minute. Then we can easily find the answer. In an hour, 6,000 drops will be accumulated. But the question is, what if the rate is not constant or if the water is flowing continuously? Okay, so let's consider another situation. We want to find the number of vehicles traveling in this road in a day. On a busy day, we can think of a stream of vehicles as continuous quantity like water. So we can see that the problem could arise when we have to add to a continuous quantity or even a discrete one. So, addition of number is one of the basic things that we learn in our childhood. So we get more efficient and faster at it once we learned how to multiply numbers. So, but when the addition becomes continuous, we have to upgrade this skill. So in this video class, we will take our skill of addition to the next level, which is, alright, the upgrade is called the process of integration. So integration is also used to find the area of the volume of the different shapes. So how can it be used to solve this problem? Okay, so actually these two things are connected to each other, the addition and the geometry. There is a relation between geometry and addition. So, for example, we can easily count the number of points currently in the screen. But what if I ask you to count this one? You could say that this question is absurd. We cannot count the number of points of a line as it's continuous. So for any 2 points on it, we can always find a point between them. So between these two, there is always a point between. So instead of total number of dots, we define the length of a line. So this was just the glimpse of the idea. So let's see what exactly do we mean by this. So I want you to imagine a situation. So okay, so I know all of you have encountered the video game because during the pandemic our faces only face the gadgets that our parents bought. So the situation is, recently you are hooked to a video game. So as you keep winning, you are rewarded with the points and you just want to keep collecting them. So you wonder how many points you would collect after 3 weeks. So luckily, the game has a feature that shows the rate at which you are earning the points. Okay, so it shows that after the t, which is the weeks, and your rate is the t squared, 1,000 points per week. Okay, so assuming that you keep earning points at this rate, so how many points will you have after 3 weeks? So you could probably say it's easy. So from this relation, you can find the rate for each week. In 1 week, the rate will be 1,000 points per week. In a week 2, 4,000 points per week. And in a week 3, would be the 9,000. Okay, so according these rates, in the first week, points earned will be 1,000. In the second week, would be 4,000. And on the third week, 9,000. So 14. That would be 14,000 in total. But is this correct? Actually, not. In these calculations, we directly assume that the rate is constant during each week, but it's not constant. These functions implies that the rate is continuously growing or changing. Its graph looks like this. So how do we find the total number of points? Okay, so for this, we need to understand what does this calculation tells us graphically. So look at this graph. So here we have the number of weeks on the x-axis, this one, and the rate of earning points on the
Here,
y-axis.
we have the number of weeks.
Okay. So this calculation implies that the rate is constant during each week. So it can be represented by the horizontal lines like this. So now notice one interesting thing. So look at these rectangles. The area of the first rectangle will be equal to the total number of points earned in the first week. How? Okay, so the height of this rectangle is equal to the rate of 1,000 points per week. So its width is equal to 1 week. So its area will be equal to 1 multiplied by 1,000, which equals to 1,000 points. So we see that the area below these horizontal lines tells us the total number of points earned during that duration. So can you find the areas of the two other rectangles for the second rectangle? It would be the 4,000 points, and for the third one will be the 9,000 points. So we get the sum of the areas of these three rectangles to be equal to 14,000 points. So this is the answer we got using calculation. So we see that the process of addition here simply becomes the finding total area covered by these rectangles. But now we know that the rate is not constant during each week. So notice in a graph that each week the actual rate is lower than the rate we considered here. Okay, so consider the first half of the week 1. Here, the rate will not be equal to 1,000 points per week. So, at the end of the first half of week 1, the rate will be 1/4 of 1,000. That is 250 points per week. So let's consider this is the constant rate throughout the first half of 1 week instead of 1,000. So alright, 1/4. So this will give us a better estimate of total number of points. So can you tell me the total points earned in this duration? Alright, so yes, it will be equal to the area of this rectangle, which is the 125 points. So if we do this for the each half of 3 weeks, we will get this graph. Alright, now we know that the total points earned will be equal to the sum of the areas of these rectangles. So after doing the calculations and adding, we will get the answer as 11,375 points. So earlier we got the total of 14,000 points, and now it's this number. This is the better estimate than the previous one because the rate considered here is closer to the graph. Okay, so what should we do next to improve our estimate further? Okay, correct. So, if we consider an even shorter duration of a week, for example, a day, so we will get an even better estimate. So, as we keep decreasing the width of the rectangles further, we see that this total area will approach the area under this curve. So we see that the problem of finding the total number of reward points becomes the problem of finding the area under the graph of this function. This one. So, this is the connection between geometry and addition. So, we mentioned earlier, in abstract terms, we can say that we have a function which represents the rate of some quantity. So, then the area under the graph of that function tells us the total amount of that quantity. Let's practice. Let's apply our knowledge that we have learned earlier from our discussion. So, okay, so thank you everyone for your participation, and that would be all for now, and I hope that you have some learnings that you can use in the future in today's discussion. Thank you so much, everyone.